In this parametric facade tutorial, I want to show you how you can produce this facade in Grasshopper. As you can see here, I can change the number of the panels. I can increase or decrease them on a freeform surface. And then we will also give a move to the tip of that triangle. As you can see here, we can increase or decrease that and produce the facade. So basically this tutorial will show you how you can have all the top of those triangles and dispatch them into two parts, and then also produce the corners and merge them together to have a complete parametric facade. Okay, first of all, you can download this definition from the parametrichouse.com website. I will also put the download link in the website in the description bar, so check it out. So first of all, what we want to do is to produce a surface, and as you can see, I have produced a surface here. We can simply draw a curve in Rhino and extrude this up, move this up, and use the control key to produce the surface. And if you extrude a curve in Rhino, be sure to first of all explode that and then rebuild the surface. Increase the number of the point counts, okay, so you have a better NURBS surface. So first I'm going to go to the params menu and the surface. Let's just put the bifocals plugin and set this to the surface so you can see this. Okay, so first we have the surface of the facade. Now we want to produce some triangular panels on the surface. So what I'm going to do, you can install the Lunchbox plugin from the website. Go to the description bar, click on the link is both of the definition and the plugin. So after downloading the Lunchbox plugin and installing it, you will have a set of panels. This is going to making panels in Grasshopper more easier and better, because you have the panel, you have the structure. So I'm going to start from this triangle panel B. You can also use another panel, but for this example I'm just use these triangle panels, and let's just use this. And let's turn this off, right click and preview off, and we can use a number maybe 12. Okay, control C, control V, and 12 for the V. Okay, we can increase the U and the V here, but as you just saw in the definition, you can see that those triangles are heading up and down. So how can we just fix this? Because this is the left and right triangle and we need the up and down. So you can simply go to the utility of the Lunchbox and use this reverse surface direction tool. And I'm going to use this reverse surface direction tool. You can give the surface here and get the output here. So we're going to reverse the direction of the surface. You can see that the reverse option is do nothing, reverse U, reverse V, and here we want the reverse UV, because we want to change the U and the V direction. So if it's UV, we will have changing the reversing the UV direction. Okay, we can simply give a tree to this. Let's give this a tree and turn this off, and here we go. So you can simply change the direction of the panels by giving a tree and reversing the UV direction. Okay, so first of all, what we need here is the panels which are pointing up, and what we want to do is to use the dispatch tool. You can also watch the dispatch tutorial and see how it works, but if we give this to the panels or to the list, you can see that the default dispatch pattern is TrueFalse. So it's going to take into two groups, the true and false. Let me just connect the surface to this. Okay, you can see that this is going to be something like this: true, false, true, false, true, false, and so on, or something like this: true, false, true, false. And we have two groups: the true, which is the downwards, the triangle downwards, and the up ones, which is the false. Okay, and what I'm going to do is to explain this V division. So when I change this V division, you can see that those even numbers will give you the correct result. But if you have an odd one, you can see that those are going up, and we don't have these ones. So I'm going to double click on the V division and make sure it's an even number. So here we go, even numbers. And the next tip is that we have to have a complete triangle up there. So we're going to change that U division. I'm going to explain that further. So let's just dismiss this part and go towards making the panels. Okay, here we have the upward triangles, and we want to work on these. So if you check the definition, you can see that the algorithm is very simple. What happens is that we have a triangle, and what we do is to move the tip of this in the normal direction. So assume that this is the normal direction. I'm going to move this in the normal direction and connect these corners something like this. This corner to this, and again to the end. And we will have this surface. Again, this corner to this and to the end of the tip. And we will have this surface. And again, we can just connect these three points to have this front one, which you can see here. Okay, so what we want to do is to move the tip of this to the front in the normal direction. So let's just work on this surface. First, I'm going to deconstruct this. So deconstruct brep, a boundary representation, because we want a solid to be deconstructed. So here we go. And we will have the vertices. As you can see here, we have 3 vertices here. So how can we just have these 3 vertices? If you have watched different tutorials, I've explained this. I also have explained that in the course, that we use the list item, and we can use this item, list item, to extract data. So we have 3 vertices here, and we can give this to the list, and we can just put this, zoom in, and give this. This is the index 0, so this is the first vertex of this. So let's just zoom in and give this a plus, and you can have the first, the second, and the third vertices here out into I +1 and +2 output. So how can we understand which one is the first one and the second and the third? One of those methods you can use is to simply use a list item before you explode that, and that means that we are picking one of those and then give this, and you can see that this is the first, this is the second, and this is the third. So we all know that this is the first, the second, and the third. So first we need the index 0 to just be moved. I'm going to delete this and turn it to all of those panels, and we're going to move this. So let's just move this. And now what we need is the normal direction, because if we give this in the y direction, assume that we give this a y direction, and let's give this a number, you can see that that's not really correct, because let's just move this, because these panels are moving in the y direction, but this one should move in the normal direction and not in the y direction. So what we want to do is to give this the normal direction, and there's going to be a simple method. We can use the face here. You can see that we have the face up here, and one of the fastest methods you can use to extract the normal direction when you have a planar surface like a triangle, something like this, you can simply go to the params menu and use the panels, or the planes, excuse me, the plane tool, and connect this to the plane. It's going to extract the plane of that, but what we need is the normal, so you can simply connect the vector to this plane. So remember, if you have a triangle or a planar surface, you can simply connect a plane to that and then connect a vector, and then you have the normal direction. So if I give this to the motion, you can see that all of those points, let's turn the plane off, has moved just 1 unit in the normal direction, we can simply give this a multiplication from the math. And here we go, we have the multiplication. We can give this a 2.56, then give it to the motion, and you can see we can control in the normal direction. And because we want to give this in the opposite direction, we want to give this motion an expression and write a minus x here. Here we go. That's it. Okay. So you can see that we have the tip of those triangles moving in the normal direction. Okay. So now we can just make the borders of that facade. Now we're going to go to the surface and use this 4-point surface. We also have a tutorial about 4-point surface, so check that out. Okay. We have to give this 4 different points, or 3. We can also give this 3 points. Okay. We want to connect this point which we moved to the tip and to this end and produce the border. Okay. So I'm going to give this, the tip was here, this was the moved one, and now we have 2 corners here. So one will be the corner C, as you can see here. We made that. Another one will be the top, the moved one, and the opposite corner is the +2. Here we have this. Okay. And now we have the whole of this panel, so I'm going to give this the moved point and 2 corners. So let's just give this 2 corners. And here we go. So if I just move this a little bit and bake all of these, you can see that we have produced that parametric facade now. Okay. So this is how we can simply produce that. We can also use a point attractor to maybe define a point and move these. A curve attractor, an image. You can also give this a random number, so we can change that. But for now, what we want to do is to work on these panels. These panels are not right because this triangle panel B+, you can see that it gives those small triangle panels which we don't want to work on. So what we want to do is to go back here, okay, and just disconnect this with a control key. Let me again put a surface here, and now I want to do something before we made that, and that is to delete or just dispatch those which are here. And what we can do is simply, let's just move this, okay, forward, and now I'm going to use an area. It's going to be simple, and you can see that there are 2 sets of panels. One is 137 area and one is 68. So we don't need these small ones. That is definitely the small ones. And what I'm going to do is do something like this. First, I'm going to sort the areas. And as you can see with the key, we can sort this from small up to the bigs. Okay. And what we need here is to define which are about 68, because you can see that 68.75 here, we have 68.76 here, so it's going to change a little bit. But what I'm going to do is to use the list item, and the list item is going to, okay, list item, I'm going to pick the first one. So the smallest possible area is this, okay. And what I'm going to use is to use the logics. We also talked about logics in the Grasshopper course, but for now, what we can do is to use the math, the operators, and here we have similarity. We can use this to define which panels are a little bit similar to that area we needed. Okay, so we're going to say those areas which are similar to this number, and we give a threshold. So threshold is a number between 0 and 1. It's a percentage of the similarity, maybe 0.2%, 1%, I don't know, maybe this is going to be enough, but we can change this, so there's going to be no problem. So based on this test, which we did here, and we extracted the area, we sorted this into small to large, then we picked the smallest, and then we checked this between the area and the smallest, we have a true-false here in the similarity. So if I just put the cursor here, you can see that there's going to be some true and false, and now we can dispatch these panels again with this similarity. Okay, just turn this off. Let's check it out. We have two set of groups, the true, which you can see are the corners, and the false, which are all the big triangles. So this is the step we need to take. Okay, I'm going to delete this to be sure we had only the big triangles. So we're going to keep this and keep these smaller ones for later. And now what I'm going to do is to also combine this triangle with this triangle and have a single big triangle here. These are the corners of the facade. So what we want to do is to be sure to have a complete triangle here, and you can see that this is just cut here. We need another one here. Okay, so what I'm going to do is to check this U division. If I change this, okay, you can see the if it's even, we have a problem here. We have the complete here, but we don't have. You can just change, you can define what you want. So if you want the whole triangle here, we can put this into even. Again, we can just put this to even. If you want this to have something like this and have a small triangle here, we can put this to odd. So remember, you can just change between even or odd based on what you want, but for now even is fine. Just thought it was using the odd ones. Okay, so now we have the we had this dispatch and we extracted the smaller ones. Now let's just head to these parts, those triangles which are pointing down. We again need those small ones instead of this one, because as you can see here, I've just combined these two to produce another layer here. We can have them here, and as you can see, let's just check this out, this combination. Okay, you can see that I have merged the faces to produce those corner panels here. So here we go. Again, what I'm going to do is to use this logic again. This time I'm going to use the list A for this, and you can see that again we have two set of panels, the small ones and the big ones. So we have this two small ones, so we can just merge them together, and let's just turn this off. And we also have the list B, which are the big triangles pointing down. So these are the three groups we need: the triangles pointing down, two set of smaller triangles which we will merge now, and at the end we have this triangles pointing up with the borders. Okay, so now let's just merge these two surfaces together. What we can do is to search for merge, and here we go, the merge faces. We can also find this in the surface, the utility, and merging two face into one. Going to merge by using the shift key. Turn this off. Let's see if it's okay. Okay, we need to merge these surfaces, but before we want to get results, as you can see in the definition, I used the join method. And what is the join method, and why didn't it work in the merge surface, in the merge faces? Because what we can do before merging is to join them. So let's just join and have a brep join. Because if I bake these, you can see that they are just out. So let's just join these as a brep, shift key. Okay, this is playing with me. Okay, let's just bake this. And now you can see that these are just joints. So remember, before merging, you have to join them. And after you joined, you can merge them. And here we go. That's the merged result. So you can define which section you want. If you want a complete triangle, you have to put this into an even number. If you put this into odd, you can see that we will have something like this and a small panel up there. Okay, so it's up to you. You can change this hue, and here we go. Okay, so now we can just bake these into one layer or simply use this custom preview tool, but let's just bake this. I'm going to put all of those surfaces into one with a shift key and bake this into layer 1. Bake this merged ones. You can have the B-reps here in the layer 2, and then we will have the layer 3. And here we go. You can see that you can have all of those in 1, 2, and 3 layers. If you want to join these 3, as you can see, they are just separated by those panels. We can again go here and join these 3 surfaces. So you can simply join them. And here it is. So this is going to be simple, and we can change this number. Okay. Let's just give this a big number because it's going to look nice, and give this the layer 1 and the layer 2 and here the layer 3. You can give them different materials, and I used Keyshot. You can use anything to give it a render, and as you can see here, we will have a parametric facade here. We can give them different materials, and as you can see, we have this. Okay, let's just go to the artistic view. You can see this view. Okay, and this is the parametric facade. So you've learned how to dispatch, how to produce the merged surfaces, and produce a beautiful parametric facade. You can also work on this to a point attractor. Maybe you can give this a point attractor here, so we have small moving up to bigger moves, and you can work on that with the Grasshopper course, or just check the point attractor tutorials if there's in the sections. Okay, thank you for watching. If you have any questions, just feel free to put it below the video, and thank you for subscribing to our channel. We will try to work on different Grasshopper tutorials in the future, and maybe in the future we will just add more tutorials on plugins, which will based on your need. Just feel free to ask, and I will try to add them into the schedule of the Grasshopper tutorials and add them to the channel. Okay, thank you for watching.